In the context of cryptocurrency and blockchain, layers typically refer to the different protocol levels or solutions that aim to scale or add functionality to the network. These layers are often categorized as Layer 1, L1, and Layer 2, L2. With some discussions also mentioning Layer 3, L3, solutions. Here's a brief overview. Layer 1, L1. This is the base layer and refers to the main blockchain itself. For Bitcoin, this would be the Bitcoin blockchain, for Ethereum, the Ethereum blockchain, and so on. L1 solutions are improvements or changes made directly to the core protocol. For instance, Ethereum's transition from proof of work, POW, to proof of stake, POS, via Ethereum 2.0 is an L1 solution. They often require consensus changes and can be more challenging to implement since they might necessitate hard forks or other major network changes. Layer 2, L2. These are secondary layers or protocols built on top of the L1 blockchain. They don't require changing the main blockchain but leverage the security of the main chain. L2 solutions are primarily used to address scalability issues. By handling transactions off the main chain, off-chain, and then settling them on-chain, they can significantly increase transaction throughput. Examples include Lightning Network for Bitcoin, a payment channel network that allows for fast, low-cost off-chain transactions. Rollups for Ethereum, solutions that bundle or roll up many transactions into a single one to be settled on the main chain. There are different types of rollups, such as ZK rollups and optimistic rollups. Plasma, a framework for building scalable decentralized applications by offloading much of the computation off-chain. State channels. These are off-chain channels that allow participants to transact among themselves directly and then settle the final state on-chain. Layer 3, L3. While less commonly discussed than L1 and L2, L3 refers to the application layer or protocols that are built on top of L2 solutions. L3 can be thought of as the dApps, tools, and services that utilize L2 solutions to further improve user experience, functionality, or scalability. The need for layers in the cryptocurrency and blockchain space primarily arises from the challenges and limitations associated with scaling and functionality. Here's a deeper dive into why these layers are essential. Scalability. Limited throughput. Blockchains like Bitcoin and Ethereum have limited transaction throughput. For example, the Bitcoin network can process approximately 7 transactions per second, TPS, and Ethereum around 30 TPS. When compared to centralized systems like Visa, which can handle thousands of TPS, this limitation becomes evident. Network congestion. During times of high demand, blockchains can become congested. This results in slower transaction confirmations and higher fees, impacting user experience. Off-chain solutions. Layer 2 solutions help address these limitations by handling transactions off-chain and later settling them on the main chain, dramatically increasing throughput and reducing costs. Flexibility and functionality. Customization. Layer 2 and Layer 3 solutions can introduce additional features and functionalities without altering the main blockchain protocol. This allows for experimentation and innovation without risking the security or stability of the main chain. Interoperability. Some layered solutions aim to bridge different blockchains, enabling interoperability between them. This can foster a more interconnected and collaborative blockchain ecosystem. Security. Leveraging base layer security. Layer 2 solutions build upon the security of the main blockchain. Even though they might handle transactions off-chain, they still rely on the main chain for final settlement, ensuring the security and immutability of those transactions. Mitigating risks. By experimenting and innovating at the L2 or L3 level, potential vulnerabilities or risks are contained within that layer, preserving the integrity of the main chain. Cost efficiency. Reduced fees. Layer 2 solutions can significantly reduce transaction fees. For instance, the Lightning Network allows Bitcoin users to transact with minimal fees by keeping most transactions off-chain. Optimized resource usage. By moving some operations off-chain, there's a reduction in the computational and storage resources required on-chain, making operations more cost-effective. User experience. Faster transactions. Layer 2 solutions can offer instant or near-instant transaction confirmations, enhancing user experience. Richer applications. Layer 3 solutions, being closer to the application layer, can introduce features and functionalities tailored to end users, leading to more versatile and user-friendly applications. Let's dive deeper into how these layers operate by looking at some of the prominent solutions and mechanisms associated with each layer. Consensus mechanism. L1 operates based on a consensus mechanism, like proof of work, POW, in Bitcoin, or proof of stake, POS, in some newer blockchains. This mechanism determines how new transactions are validated and added to the blockchain. Blocks. Transactions are grouped into blocks. Miners, in POW, or validators, in POS, then validate and add these blocks to the blockchain. Final state to the blockchain. dApps. Decentralized applications can be built on L2 solutions to provide faster, cheaper, and more interactive experiences to users. They can leverage the benefits of L2 while providing users with functionalities similar to traditional apps. Cross-chain bridges. These are protocols that enable communication and value transfer between two different blockchains. They can be built upon L2 solutions to facilitate interoperability. Tooling and services. Various tools and services, from wallets to analytics platforms, can be developed on L3 to support and enhance the ecosystem. The layered architecture of cryptocurrencies has been influenced by a myriad of developers, researchers, and thought leaders in the blockchain space. Some of the most influential figures who have contributed directly or indirectly to the development or conceptualization of these layers include Satoshi Nakamoto, the pseudonymous creator, of Bitcoin, introduced the concept of a decentralized digital currency using a proof-of-work blockchain. Vitalik Buterin, co-founder of Ethereum, introduced the idea of a general-purpose blockchain that supports smart contracts, which paved the way for many Layer 2 solutions built on Ethereum. Joseph Poon and Thaddeus Dryja, co-authors of the Lightning Network white paper, a prominent Layer 2 scaling solution for Bitcoin. Joseph Poon and Vitalik Buterin, co-authors of the Plasma white paper, an L2 scaling solution for Ethereum. Jinglin Wang, Carl Floersk, and others, have worked on optimistic rollups, a type of Layer 2 scaling solution for Ethereum. Zoako Wilcox O'Hearn, founder of Zcash, has been involved in the development and promotion of ZK Snarks, a form of zero-knowledge proof which is used in ZK rollups. Another L2 solution. Lightning Network team, developers behind the Lightning Network, an off-chain scaling solution for Ethereum, similar in concept to Bitcoin's Lightning Network. Starkware team, a company focused on developing ZK Starks, a form of zero-knowledge proof without trusted setup, which can be used for L2 solutions. Arthur Brightman, co-founder of Tezos, a blockchain that introduced a formal on-chain governance model. While not an L2 solution, it's an innovative L1 approach to scalability and adaptability. Cosmos and Polkadot teams, both projects focus on blockchain interoperability, and while not strictly L2 solutions, they represent efforts to bridge different Layer 1 blockchains. EV, Compound, and other DeFi teams. While these teams are more focused on building decentralized financial applications, their work often leverages Layer 2 solutions or drives the need for L2 and L3 innovations. These are just a handful of the many influential figures and teams in the blockchain space. The development of layered architectures in the blockchain is a collaborative effort, with contributions from countless developers, researchers, and enthusiasts around the world. The base layer, Layer 1, of blockchains provides a secure and decentralized foundation. It often comes with limitations in terms of scalability, cost, and flexibility. Layer 2 and Layer 3 solutions are instrumental in addressing these challenges, making blockchain technology more practical and accessible for a broader range of applications and users. While Layer 1 provides the foundational security and decentralization of the network, Layer 2 solutions introduce mechanisms to increase scalability, reduce costs, and improve speed by cleverly leveraging the security of L1. Layer 3, on the other hand, is more about enhancing the ecosystem by building on top of L1 and L2 solutions to provide better applications and services. As the blockchain and cryptocurrency space has evolved, different layers have been introduced to address various challenges, particularly those related to scalability and usability. While L1 is the foundational layer representing the main blockchain, L2 and L3 solutions are built on top to enhance and expand the network's capabilities. Now you know what blockchain layers are. Please like the video if you did. Please subscribe if you'd like to see more. Please comment if you'd like. Thank you for your time.